We've discussed the various types of fractions, so today what we'll look at is basic operations with fractions. So the first operation that we'll look at is multiplication. And we will look at multiplying either two proper fractions or two improper fractions, or a proper fraction and an improper fraction. Either rate, the rules are the same. So to multiply two proper fractions, you multiply the numerators and you multiply the denominators, and then you see if the product is in lowest terms. If it's not, you have to express it in lowest terms. So I'm going to multiply numerator times numerator and denominator times denominator. So 3 times 5 is 15, and 4 times 7 is 28. Now I need to determine if this can be reduced, so what I'm going to do is I'm going to look at the factors of the smallest number, which is 15. So the factors of the smallest number, 15, are 1, 3, 5, and 15. So see if the denominator is divisible by 3, 5, or 15. And 28 is not divisible by 3, 5, or 15, so therefore it is in lowest terms. So 3/4 times 5/7 is equal to 15/28. Here's another example of multiplying two proper fractions. So you multiply the numerators and you multiply the denominators. So 7 times 9 is 63, and 12 times 10 is 120. However, 63 over 120 can be reduced. Each of these two factors contain each one of these two numbers contains a factor of 3. So I can divide 3 out of both the numerator and the denominator. So 63 divided by 3 is equal to 21. And 120 divided by 3 is equal to 40. And again, the factors of 21, which is the smallest number here, are 1, 3, 7, and 21. And 40 is not divisible by 3, 7, or 21. So this fraction is in lowest terms. So 7/12 times 9/10 is equal to 21 over 40. Now I'm going to show you something that you can do to make the arithmetic a little easier. Here, what I'm going to do is cancel. Whenever you can cancel, you need to do so because it does make the arithmetic easier. You can cancel diagonally or up and down, but you cannot cancel straight across. So by cancel, what I mean is divide a common factor out of each of these two terms. 12 and 9 contain a common factor of 3. So I can divide both 12 and 9 by 3. It has to be the same number. That's why we call it a common factor. 12 divided by 3 is 4, and 9 divided by 3 is 3. Now I'll multiply the remaining numbers. Numerator times numerator. 7 times 3 is 21. And denominator times denominator. 4 times 10 is 40. So not only does cancellation make your arithmetic easier, it also makes it easier for you to express your product in lowest terms. Now you can only cancel when you are multiplying. You cannot cancel in addition or subtraction or division. Again, we're multiplying two proper fractions. If I can, I want to avoid multiplying 9 by 35 and 5 by 27. So I'm going to see if I can make this problem easier by canceling or dividing out common factors. So I have a common factor in 5 and 35. Both 5 and 35 are divisible by 5. So I'm going to divide 5 out of each one of these numbers here. So 5 divided by 5 is 1, and 35 divided by 5 is 7. Now, if I don't do anything else to this problem, I have certainly made the arithmetic easier. However, here I can cancel again, because 9 and 27 both contain a common factor of 9. So I can divide both of these numbers, 9 and 27, by 9. So 27 divided by 9 is 3, and 9 divided by 9 is 1. Now multiply the numerators. 1 times 3 is 3, and 1 times 7 is 7. Can't get any easier than that. In this section, we're going to look at multiplying a whole number by a proper fraction. Every whole number can be expressed as a fraction, with the numerator being the whole number itself and the denominator being 1. So if I want to express 8 as a fraction, the numerator itself would be the whole number and the denominator would be 1. Now remember, as we had earlier alluded to, the fractional bar is nothing more than a division sign. See, it looks like a division sign. So 8 divided by 1 is equal to 8. So every whole number can be expressed as a fraction. So 6 as a fraction would be equivalent to 6 over 1. So in this section, we want to multiply a whole number by a proper or improper fraction. For example, suppose I have 5 times the fraction 3/4. Well, 5 is equivalent to 5 over 1 times 3 over 4. Now I'll multiply as I did before. Numerator times numerator and denominator times denominator. So 5 times 3 is 15 and 1 times 4 is 4. Now this is a improper fraction. And what I want you to do is express all improper fractions as mixed numbers. So recall to express an improper fraction as a mixed number, I divide the numerator by the denominator. So 4 will go into 15 3 times. 3 times 4 is 12, and I have 3 left over, so I take the remainder, which is 3, and write it over the denominator, which is 4. So 15/4 is the same as 3 and 3/4. So suppose I want to multiply 8 times 5/16. So again, what I'm going to do is take the whole number, which is 8, and express it as a fraction, because every whole number can be expressed as a fraction. So this is 8 over 1 times 5 over 16. And then I'm going to multiply as I did before, numerator times numerator, denominator times denominator. But remember, when I multiply, I can often make the arithmetic easier by canceling or dividing common factors out. So 8 and 16 both contain a common factor of 8. So I'm going to divide 8 by 8, which gives me 1. I'm going to divide 16 by 8, which gives me 2. And again, you have to divide these two numbers by the same number. In other words, I wouldn't want to divide 8 by 4 and 16 by 8. It has to be a common factor. Common means same. So now I have 1 times 5 is 5, and 1 times 2 is 2. And again, that's an improper fraction because the top's larger than the bottom. So I'm going to divide 2 into 5. 5 divided by 2 is 2. 2 times 2 is 4. If I subtract 4 from 5, I have 1 left over. So 5/2 is equal to 2 and 1/2. Now here we are looking at multiplying a mixed number by a proper or improper fraction. Now this is a very important concept, particularly step 1. Anytime you're multiplying, and or dividing, as we'll see later on, anytime you're multiplying or dividing and you encounter a mixed number, you need to change that mixed number to improper fraction. That's the first thing that you need to do. So here we have an improper fraction. So I need to change this mixed number to an improper fraction. We have a mixed number, I'm sorry. We have a mixed number, so I need to change that to an improper fraction. To remember, to change a mixed number to improper fraction, you multiply the whole part times the denominator. Whole part times the denominator, and then you add the numerator. Whole part 3 times the denominator 5, which is 15. Add the numerator. 15 and 3 is 18, and you place that all over the denominator. So that becomes 18 fifths times 5 twelfths. Now, do not cancel. Do not do anything until you have changed your mixed numbers to improper fractions. Then we're going to multiply as we did before. Numerator times numerator, denominator times denominator. But keep in mind, when we multiply, we can often make the arithmetic easier by canceling or dividing out common factors. So here, 5 and 5, of course, each one of those is divisible by 5. So 5 divided by 5 is 1. Here, 18 and 12 are both divisible by 6. So we're going to divide 6 out of each one of those. Now, there may be a case when you do not have any common factors. If you do not have any common factors, you cannot divide a common factor out. Then you simply multiply numerator times numerator and denominator times denominator. But when you can, I encourage you to cancel or divide out any common factors when multiplying fractions, so that it does two things. It makes the arithmetic easier, and it makes it easier for you to express your product in lowest terms. So 18 and 12 both contain a common factor of 6, so I'm going to divide 12 by 6, which gives me 2. I'm going to divide 18 by 6, which gives me 3. So now I'm going to multiply numerator times numerator. 3 times 1 is 3. And denominator times denominator. 1 times 2 is 2. And that's equal to 1 and 1/2. Again, I want you to express all improper fractions as mixed numbers. Here I'm multiplying 2 and 2/9, which is a mixed number, times 4 and 4/5. And again, anytime I'm multiplying, look at the first step. You have to express those mixed numbers as improper fractions. Now, it would be incorrect to multiply the two whole parts and then multiply the two fractional parts and add them together. That would not give you the correct answer. So I need to change 2 and 2/9 to an improper fraction. So 2 times 9, whole part times denominator. 2 times 9 is 18, plus the numerator. 18 plus 2 is 20, all over the denominator, which is 9, times, and again, I'm going to change this mixed number to an improper fraction. 4 times 5 is 20, whole part times denominator. Whole part 4 times denominator 5. 4 times 5 is 20, plus the numerator. 20 plus 4 is 24, all over the denominator, which is 5. Now again, if I can avoid it, I want to avoid multiplying 20 times 24. So I'll look at the numbers that I have here and see if I can divide out any common factors. Remember, you can cancel diagonally or straight up and down, but not straight across. So here, 20 and 5 both contain a common factor of 5. So I'm going to divide 5 out of each one of these numbers. So 5 divided by 5 is 1. 20 divided by 5 is 4. And it also is the case that here 9 and 24 both contain a common factor. Both contain a common factor of 3. So I'm going to divide each one of these by 3. 9 divided by 3 is 3. And 24 divided by 3 is 8. So now I'm going to multiply numerator times numerator. 4 times 8 is 32. And 1 times 3 is 3. And again, this is an improper fraction, so I'd like for you to express that as a mixed number. So I'm going to divide the numerator, 32, by the denominator, which is 3. 3 goes to the 3 one time. 1 times 3 is 3. Drop down the 2. 3 will not go into 2, so I put a 0 here to hold the place. 0 times 3 is 0. So I have a remainder of 2. So I take my remainder, which is 2, and place it over my denominator, or my divisor here, which is 3. So this is equal to 10 and 2/3. Again, we're multiplying two mixed numbers, and the first step in multiplying mixed numbers is to make sure that you express each mixed number as an improper fraction. So again, I have two mixed numbers, so I need to change each of those mixed numbers to improper fraction. 6 times 3 is 18, plus 2 is 20, so this is 20 over 3, times 2 times 4 is 8, plus 1 is 9, so that's 9 over 4. And again, if I can, when I'm multiplying, I'm going to try to cancel any common factors, because it does two things. It makes the arithmetic easier, and it also makes it easier for us to express the product in simplest terms. Now, in this class, it goes without saying, anything that we do that involves fractions, we always express our answer in lowest terms. So looking at 20 and 4, both 20 and 4 both contain a common factor of 4. So I can divide 4 out of each of these two numbers. So 4 divided by 4 is 1. 20 divided by 4 is 5. And likewise, 3 and 9 contain a common factor of 3. So I can divide 3 out of each one of these numbers. So 9 divided by 3 is 3. 3 divided by 3 is 1. And now I'll multiply as I did before, numerator times numerator and denominator times denominator. So 5 times 3 is 15, and 1 times 1 is 1, and 15 divided by 1 is simply the whole number 15. We have completed our discussion on multiplication of fractions and mixed numbers, so now we want to move on to division. And to divide by a fraction, you multiply by its reciprocal. So let's look at what that means in the example that we have listed below. So I have 3/5 divided by 7/9. So I'm dividing by a fraction. This is my divisor. The number that I'm divided by is called the divisor. So I'm dividing by a fraction. So to divide by a fraction, I multiply by its reciprocal. The reciprocal of 7/9 is simply 9/7. So in essence, what I'm doing is I'm changing all division problems to multiplication problems. And I call this the Colonel Sanders recipe for division, or KFC. Because what I do is I keep the first fraction as it is. I do not do anything with the 3/5. I flip the second fraction. I have 7/9 here, so it becomes 9/7. And I change the division to multiplication. So now I'll multiply as I did before. Numerator times numerator. 3 times 9 is 27. And 5 times 7 is 35. Now, let me caution you. Caution sign. You cannot cancel in multiplication. You cannot cancel in division, addition, or subtraction. So do not cancel the 3 and 9 because you have a division sign present. So do not cancel until after KFC, because once you apply the rule for division, which states that you basically keep the first fraction and you invert or flip the second fraction and change the division to multiplication. You have created a multiplication problem. Once you have applied KFC, then and only then can you cancel if you have common factors. But you cannot cancel if there is a division sign present, or addition or subtraction for that matter. Here again we're dividing 7/9 divided by 21 over 63. So I'm going to use my friend the great Colonel's recipe for division, which is keep. So I'm going to keep the 7/9. I'm going to flip the second fraction, so that becomes 63 over 21. And I'm going to change my division to multiplication. Now again, I don't necessarily want to multiply 7 times 63 unless it's absolutely necessary. So I look at these numbers. Now that I have applied the Colonel's recipe, it is a multiplication problem. So now I can cancel. 7 and 21 contain a common factor of 7. So I'm going to divide 7 out of each one of these. So 7 divided by 7 is 1. 21 divided by 7 is 3. 9 and 63 also contain a common factor. Each one of these numbers here is divisible by 9. So 63 divided by 9 is 7. And 9 divided by 9 is 1. So now I'll multiply numerator times numerator, denominator times denominator. 1 times 7 is 7, and 1 times 3 is 3. And again, this is an improper fraction because the top's larger than the bottom. So I'm going to divide the numerator by the denominator. So that gives me 2 and 1/3. Here I'm dividing two numbers that are actually mixed numbers. So again, anytime you multiply or divide and you encounter a mixed number, you need to change those mixed numbers to improper fractions. That needs to be your first step. So I'm going to change 3 and 3/4 to improper fraction. 3 times 4 is 12, plus 3 is 15, so that's 15/4 divided by 2 and 5/8 as an improper fraction would be 2 times 8, which is 16, plus 5, which is 21, all over 8. Now the only thing I've done in the first step here is simply change the mixed numbers to improper fractions. Now I still need to apply my friend the Colonel's recipe, which is keep the first fraction, flip the second fraction, and change the division to multiplication. Now once I apply the procedure for division of fraction, or as I'll call it KFC, then I have created a multiplication problem. So once I create a multiplication problem, then I can make the arithmetic easier by dividing out some common factors. But you can only cancel in multiplication, not in division, up here, not in subtraction, and not in addition. So 15 and 21 both contain a common factor of 3, so I'm going to divide each one of these numbers by 3. 15 divided by 3 is 5. 21 divided by 3 is 7. 4 and 8 both contain a common factor of 4, so I'm going to divide each of these by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So now I'm going to multiply the numerators. Numerator times numerator. 5 times 2 is 10. And denominator times denominator. 1 times 7 is 7. Again, this is an improper fraction because the top's larger than the bottom. So I'm going to express it as a mixed number. So in this class, until you've told otherwise, I want you to express all improper fractions as mixed numbers. So 7 going to 10 one time, you have 3 left over. So this is equivalent to 1 and 3/7. Last example, division. Again, we have two mixed numbers here. And anytime you multiply or divide and you encounter a mixed number, the first thing that you need to do before you do anything else is change those mixed numbers to improper fractions. So 10 times 6 is 60, plus 5 is 65, all over 6, divided by 1 times 18 is 18. 18 and 7 will give you 25 all over 18. So the only thing I've done in step 1 is change the mixed numbers to improper fractions. I still need to apply Colonel's recipe, which is keep, flip, change for division of fractions. So I keep the first fraction as it is, I flip the second fraction, and I change the division to multiplication. Now here I have a multiplication problem. So when I multiply, I can sometimes make the arithmetic easier by dividing out common factors. So 25 and 65 both contain a common factor of 5, so I'll divide 5 out of each one of these terms. So 25 divided by 5 is 5, and 65 divided by 5 is 13. 6 and 8 also contain a common factor of 6, so I can divide 6 out of each one of those numbers. So 6 divided by 6 is 1, 18 divided by 6 is 3. So now I'll multiply numerator times numerator. 13 times 3 is 39. And denominator times denominator, 1 times 5 is 5. And again, this is an improper fraction because the top's larger than the bottom. So I'm simply divide the numerator by the denominator. 39 divided by 5 is 7. 7 times 5 is 35. So I have 4 left over, and I have a denominator of 5. So 10 and 5 sixths divided by 1 and 7 eighteenths is 7 and 4 fifths. To add or subtract fractions, you must have a common denominator. In order to add or subtract fractions, you must have a common denominator. Here we have a common denominator of 12. Life is good when it comes to adding or subtracting fractions if you have a common denominator. Because if you have a common denominator, to add or subtract fractions, all you do is add or subtract their numerators, whichever the case may be. So this is addition, so I'm going to add the 5 and 1, which gives me 6, and keep the common denominator, which is 12. So to add or subtract fractions, you must have a common denominator. If you have a common denominator, then you simply add or subtract their numerators and keep the common denominator. And of course, in this class, it goes without saying that anytime we're working with fractions, we always express our answer in simplest terms. So here, both 6 and 12 contain a common factor of 6, so we can divide 6 out of each of these numbers, which gives us an answer of 1/2. The same is true for subtraction. If we have 8/9 minus 2/9. Again, in order to add or subtract fractions, we must have a common denominator. Here we have a common denominator, so we simply subtract the numerators. 8 minus 2 is 6, and keep the common denominator, which is 3. And again, it goes without saying that in this class, we always express our answers in lowest terms. So 6 divided by 3 is 2, and 9 divided by 3 is 3. So 8/9 minus 2/9 is equivalent to 2/3. Before we look at adding or subtracting fractions with unlike denominators, there are 2 prerequisite skills that we need to talk about. One is the least common multiple. The least common multiple is the smallest number that is a multiple of both numbers. For example, suppose I ask you to find the LCM of 9 and 12. Now, caution, the LCM of 9 and 12 is not 3. Three would be a common factor. I'm not looking for a number that will go into 9 and 12. I'm looking for a number that both 9 and 12 will go into. And not only am I looking for a number that is divisible by both 9 and 12, I'm looking for the smallest such creature. So the LCM of 9 and 12 is 36. Because 36 is a multiple of 9, and 36 is also a multiple of 12. If you're not sure how to find the LCM, you can simply start with your two numbers, and you can find multiples of each. For example, 1 times 9 is 9, 9 times 2 is 18, 18 times 3 is 20, 9 times 3 is 27. Nine times 4 is 36, or simply just keep adding 9 to the previous number. 36 and 9 is 45, 54, 63, 72, 81, 90, etc. And make your lists fairly extensive. Now look at multiples of 12. 1 times 12 is 12, 2 times 12 is 24, or simply keep adding 12 to the previous number, 36. Stop when you get a match. So 36 is the LCM of 9 and 12. All of these numbers are multiples of 9. All these numbers are multiples of 12. So I'm looking for a number that is both a multiple of 9 and 12. So that number has to appear in both lists, and has to be a multiple of 9 and at the same time a multiple of 12. Now, of course, that's not the only multiple of 9 and 12. If we keep adding 12 here, 36 and 12 is 48, 48 and 12 is 60, 60 and 12 is 72. So 72 is both a multiple of 9 and also a multiple of 12. But it's not the smallest such creature, and I want the smallest such creature that is a multiple of both numbers. So here, the LCM of 9 and 12 would be 36. Here I will find the LCM of 15 and 24. So again, I'm just make a list, and I'm going to look at multiples of 15. And the list is going to be fairly extensive. So just keep adding 15. 15 and 15 is 30. 15 30 is 45, 60, 75, 90, 105, 120, 135, 150, 165, etc. Now I'm going to do the same thing with 24. Now remember, I'm going to stop when I find a match. So keep adding 24 repetitively. 24 and 24 is 48. 48 and 24 is 72. 72 and 24 is 96. 96 and 24 is 120. I have a match. So the LCM of 15 and 24 is 120. The next concept that we're going to use is expressing a fraction in higher terms. We'll need this concept along with finding the LCM in order to add or subtract fractions with unlike denominators. So let's look at how we'd express a fraction in higher terms. So to express a fraction in higher terms, I'm going to divide the denominator of the higher fraction by the denominator of the lower fraction. 32 divided by 4 is 8. So that gives me a quotient of 8. So I'm going to take that quotient of 8 and multiply it times the numerator of the lower fraction. 3 times 8 is 24, and that gives me the numerator of the higher fraction. In essence, what I'm doing is I'm just multiplying 3/4 by a strange form of the number 1. 8 over 8 is 1, and 1 times anything is that anything. So 3 times 8 is 24, and 4 times 8 is 32. So I haven't really changed the value of this fraction. This fraction is equivalent to what I started out with because I just multiplied 3/4 by a strange form of the number 1. And 1 times anything is that anything. Another way that you can look at this is you can ask yourself, what have I got to multiply the denominator here by to obtain the denominator of the higher fraction? So in other words, you're asking yourself, what have I got to multiply 4 by to get 32? Well, the answer is 8. I'd have to multiply 4 by 8 to get 32, so that means I've got to multiply the numerator by the same thing. 3 times 8 is 24. So either way you want to take a look at that, you may interpret it either way. So let's look at another example. Suppose I have 5, 6. And suppose I want to write it in terms of a fraction with a denominator of 42. So I'm going to divide the denominator of the higher fraction by the denominator of the lower fraction. 42 divided by 6 is 7. So that means I'm going to have to multiply the numerator of the lower fraction by 7. 5 times 7 is 35 to obtain the numerator of the higher fraction. And again, what I'm doing is simply multiplying both the numerator and denominator by a strange form of the number 1. 6 times 7 is 42. 5 times 7 is 35. Here we have 4/9 minus 1/4. Here we have two fractions which have unlike denominators. Now remember, in order to subtract fractions, we must have like denominators. If we do not have like denominators, we have to rewrite the fractions as equivalent fractions. So I've got to rewrite 4/9 and 1/4 as equivalent fractions, which means I'm going to write them in higher terms. But I've got to rewrite them in higher terms using the same denominator. So our common denominator will be the LCM of 4 and 9. So the first thing I need to do is find the LCM of 4 and 9. So if you do not know what the LCM of 4 and 9 will be, what you need to do is just make a list and look at the multiples of 4, look at the multiples of 9, and stop when you have a match. So 4 and 4 is 8, 12, 16, 20, 24, 28, 32, 36, 40. The multiples of 9 are 9, 18, 27, 36. Stop, I have a match. So the LCM, or the common denominator, for these two fractions will be 36. Now remember, do not subtract the numerators. Do not subtract the denominators. That's not how you add or subtract fractions. In order to add or subtract fractions, you must have a common denominator. And I also like to rewrite the problem, if it's addition or subtraction problem, in column form, so that I can easily find my numerator for my fraction written in higher terms. So 36 divided by 9 is 4, and 4 times 4 is 16. 36 divided by 4 is 9, and 1 times 9 is 9. Now I can subtract these two fractions because I have like denominators. So to subtract two fractions with the same denominator, you subtract the numerators. 16 minus 9 is 7. And keep the common denominator, which is 36. Here I'm subtracting two mixed numbers, but that's okay. Again, what I'm going to do is take these two fractions, or actually mixed numbers, and I like to write those in column form. Now, something is very important. When we're adding or subtracting, do not express the mixed numbers as improper fractions. It would not be wrong if you did so, but it would just create a lot of unnecessary and sometimes very messy arithmetic. For example, 12 times 24 plus 7. You see how messy the arithmetic is going to be here if I opt to change the mixed number to improper fraction. And I'd still have to find a common denominator, which means that I'm still going to have to express these two fractions here as equivalent fractions in higher terms, which would make it even messier. So you do not want to do that. You only express the mixed numbers as improper fractions when you're multiplying or dividing. So how do we do this? Well, the easiest way is simply bring over the whole part and find the LCM for your fractional part. So we're going to find the LCM for 24 and 15. Now we could make our list here, but this is one of the examples that I did for you prior where I did make a list, and I found that the LCM for these two were to be 120. So the LCM for 24 and 15 is 120 from one of the previous examples that I have done. So now we need to express 7/24 as a higher fraction using the denominator of 120. So 120 divided by 24 would be 5, and 5 times 7 is 35. So 35 over 120 is the same as 7/24. And 15, we'll go into 120. 8 times. And 2 times 8 is 16. So 120 divided by 15 is 8. 8 times 2 is 16. So now I have like denominators, so I subtract the numerators. 35 minus 16 is 19. Keep the common denominator, which is 120. And 12 minus 5 is 7. Again, we're adding two mixed numbers, but we still have to find a common denominator, or the LCM, of the two denominators. In order to add or subtract fractions, we always need a common denominator. So the LCM of 5 and 20 would be 20. So it is possible for one of the denominators to be the LCM. So 20 divided by 5 is 4. 4 times 3 is 12. And of course, I could still use the same process here, but since the denominators of both are 20 here, the numerator will also be 17. But I can still use the same process. 20 divided by 20 is 1. 1 times 17 is 17. So in order to add fractions, I must have a common denominator, which I have. So I'm going to add the numerators. 12 and 17 is 29. and 4 and 2 is 6. However, here you have an improper fraction contained within a mixed number. So do not leave an improper fraction within a mixed number. So we're going to rewrite 29/20ths. I'm going to change this improper fraction here to a mixed number. So 29 divided by 20 is 1. And I have 29 minus 20 is 9. So 29/20ths is equal to 1 and 9/20ths. Please do not write that as your answer, because 6 is not equal to 1. Just this portion of this mixed number is or this portion of this improper fraction is equal to this mixed number, which is 1 and 9/20ths. But we had 6 to begin with. So 6 plus 1 gives us 7. So that's 7 and 9/20ths. Again, in order to add fractions, you must have a common denominator. And the common denominator is found by finding the LCM of your two denominators. Again, when we're adding or subtracting fractions, do not change the mixed numbers to improper fractions. You only do that in a multiplication and division. The LCM of 7 and 5 is 35. So I'm going to write 3/7 in higher terms. 7 will go into 35 5 times. 5 times 3 is 15. 5 will go into 35 7 times. 7 times 4 is 28. So now that the denominators are the same, in order to add these two fractions, I'm going to simply add their numerators. So 15 and 28 is 43. Keep the common denominator, which is 35. Add the two whole numbers, and that gives me 10. And again, I have an improper fraction within the mixed number. So I don't want to leave that improper fraction within that mixed number. So 45 35ths. If I divide 43 by 35, 35 goes into 43 one time. If I subtract 35 from 43, I have 8 left over. So 43 over 35 is equal to 1 and 8/35. But now remember, you have 10 here. So 10 plus 1 is 11 and 8/35. Again, here we are subtracting two mixed numbers. But again, in order to subtract fractions, we must have a common denominator. So we need to find the LCM of 4 and 9. Now, the LCM of 4 and 9 is 36. In fact, we used these same two denominators in a previous problem. So I need to rewrite 2/9 as a fraction in higher terms using the denominator of 36. So 36 divided by 9 is 4. 4 times 2 is 8. Again, my denominator is 36. My denominator here is 4. So I've got to write 3/4 as an equivalent fraction using the denominator of 36. So 36 divided by 4 is 9. 9 times 3 is 27. But here I have an issue. I can't take 27 from 8 because 27 is larger than 8. So here I'm going to have to borrow 1 from the whole number. So I've got to borrow 1 from the 5. So mark it out and make it 4. Now this does not become 18. This is not tenths. My fraction is not tenths. So I cannot add 10 and 8. The one that I borrow, the whole number that I borrow, I may express as a fraction in the form something over itself. I borrowed 1 from the 5. The one that I borrow is equal to 36 over 36. any number over itself is equal to 1. 36 divided by 36 is 1. That's the one that I borrowed. So the one that you borrow, you must express as a fraction in the form something over itself. And not only is it going to be something over itself, it's going to be whatever the common denominator is, which in this case is 36, over itself. So it's 36 over 36. So that gives me 4. Now, you had 8 36s to begin with. You borrowed one, which is 36 36s. So you combine these two. 8 and 36 gives you 44 over 36. Minus 2 and 27 over 36. Now the purpose for borrowing is now you can subtract 27 from 44 because 44 is larger than 27. Now 4 and 44 over 36 is the same as 5 and 8 36s. This mixed number is equivalent to this one. They're the one and the same creature. 36 will go into 44 one time. 4 and 1 is 5. If you subtract 36 from 44, you have 8. But the purpose for borrowing is so now that I can subtract 27 from 44. So if I subtract 27 from 44, that gives me 17. Keep the common denominator, which is 36, and 4 minus 2 is 2. Caution, do not subtract the whole part first, because in some cases you may need to borrow. Now, if I found a common denominator, and the numerator here, say, was 30, and my numerator here was 27, then I would not have to borrow. You don't always have to borrow. But when you do, the one that you borrow, you're going to express as a fraction in the form something over itself. Anything over itself is equal to 1 except for 0 over 0, which is undefined. And not only is the one that you borrow going to be some number over itself, in particular, it's going to be whatever the common denominator is over itself. Again, when we're adding or subtracting fractions, we do not change those mixed numbers to improper fractions. So you just bring the whole part over, but you still have to find a common denominator for your two fractional parts. So I need to find the LCM of 6 and 9. And the LCM of 6 and 9 is 18. Now, of course, I could use 36. 4 times 9 is 36. 6 times 6 is 36, but it's not the smallest such creature. So if I were to use 36, it would not be incorrect. I would just have more reduction to do after I subtract. So I need to take 2/9 and write it as an equivalent fraction using the denominator of 18. So 18 divided by 9 is 2. 2 times 2 is 4. Again, I got to take 5/6 and rewrite it as an equivalent fraction using the denominator of 18. 18 divided by 6 is 3. 3 times 5 is 15. Now I'm subtracting here. And again, I have an issue. I can't take 15 from 4 because 15 is greater than 4. So I'm going to have to borrow 1 from the 6, so cross it out, make it 5. And the one that I borrow is going to be expressed as something over itself. And in particular, it's going to be the common denominator over itself. My common denominator is 18. So the one that I borrow here is going to be 18 over 18. 18 divided by 18 is 1. That's the one that I took from the 6. I've just expressed it as a fraction, 18 over 18. Now, again, I had 4 18ths to begin with. The one I borrowed is 18 18ths, so I'm going to combine the 4 and the 18, which gives me 22 18ths, minus 4 and 15 18ths. The purpose for borrowing is now I can subtract 15 from 22, which gives me 7 18ths, and 5 minus 4 is 1. Two final examples here. Here I have a whole number subtract, and I'm subtracting a mixed number from it. Here I have a mixed number, and I'm subtracting a whole number from it. Make sure you understand the difference between these two cases. So let's look at the second case and ask yourself what is being subtracted. Well, the only thing I'm subtracting here is 6. So this is equivalent to 6 and no 8s. I have 0 8. 0 divided by 8 is 0. So 5 minus 0 is 5. 12 minus 6 is 6. So in essence here, all I have to do is subtract the whole number from the whole number above it. So let's get rid of the 0 8s here. So the only thing I'm subtracting is 6. 12 minus 6 is 6, and you drop down to 5 8s. Now, in the example above, it's a totally different situation. Ask yourself, what is being subtracted? 3 and 4/5. This is 8 subtract 3 and 4/5. So not only do you have to subtract the 3 from something, you have to subtract the 4/5 from something. This is 8 subtract 3 and 4/5. So the 3 has to be subtracted from something as well as the 4/5. Now if you just drop the 4/5 down, you have not subtracted it from anything. So you look up here and there's nothing to subtract the 4/5 from. So that means you got to borrow 1 from the 8. So I'm going to borrow 1 from the 8, makes that 7. And the 1 that I borrow, I'm going to express as something over itself. In fact, not only is it going to be something over itself, it's going to be denominator over denominator. We'll only have one fraction here, and its denominator is 5. So the 1 that I borrow, I'm going to express as 5 over 5. 5 over 5 is 1. That's the 1 I borrowed. 7 and 5 over 5 is equivalent to 8. But now I can subtract 4 from 5, which gives me 1. And now I can subtract 3 from 7, which gives me 4. If you're not sure if you've done this correctly or not, remember, how do we check subtraction? We add. So if I add 6 and 6 and 5 eighths, that gives me 12 and 5 eighths. If I add 4/5 and 1/5, that gives me 5/5. And if I add 3 and 4, that gives me 7. But 5/5 is the same as 1. 1 and 7 gives me 8, which is what you started with.